Okay, so for number one, since this arc was 25, that means this arc down here is also going to be 25. What's the total degrees of this arc over here?
90.
That's a total of 90 over there. How much does that leave for the rest of the circle? 270. Okay, so that left 270 degrees for this blue part. So the blue part is 270. So what does that mean for each side? So that means divide by 2 is 135. Okay? So that's the answer to number 1. So on problem number 2, CE is 8, ED is 5. Could you get the door for me, brother? It's a little loud out there. EB is 10, and we're supposed to find AE, which I'll call X. What's the property that we're supposed to use for this one?
Part times part equals top. Part times part.
Correct. This is one where we do part times part equals part times part. So 10x should equal 8 times 5. So, of course, that means 10x is equal to 40. So x is equal to 4. Any questions on number 2?
No. No, sir.
Okay. Moving on to number 3. Okay. Wait, hold on, let me zoom in a little bit. Alright, so looking at problem number 3. Can you tell me the degrees of arc PQ? Only one person? Austin said 90. Does the rest of y'all knew that? I hope. Okay. If it's at the center, the arc and angle should be the same. So that's how we knew it was 90. If this arc is 90, can you tell me what that angle is back there? Go the other direction. The angle is right. The angle is small. Angle is half of the arc, so 45. Okay. And that's what we were supposed to find, angle PRQ, so 45 degrees. So that's number 3. Any questions? No. Nope. Okay. Looking at number 4. We are given angle AMB is 50. That means this right here is 50. Can you tell me what the other angle would be right next to it, right here? That's going to be 130. Can everybody see why?
Yes.
It's a straight line, 180 degrees. So subtract 50 from 180, you get 130. So that's 130. That means, what about the arcs? What's this arc AB going to be? That's going to be 50. What about this arc over here? Yeah, the arcs and the angles are the same when they're at the center. So that's 50, and this is 130. What about this arc around the backside?
180.
Yeah, that's a semicircle. So boom, 180, semicircle. So between those 3 numbers, we should be able to answer all the questions. So what's the measure of arc AB?
50.
That's 50. That's right there. What about ACB?
310.
How did he get 310, you guys? Yeah, let me make it 100% clear. Please understand that arc ACB is the major arc that goes around the long way. Whoops, I kind of missed. ACB goes around the long way from A past C and all the way back around to B. So it's the whole circle except for the 50. So you could have started with 360 and then subtracted 50. So 310. Any questions right there? What's the measure of BC?
130.
Yeah, 130. We already did that. So that's number 4. Any questions about number 4? Okay. Moving on. Looking at number 5. They gave us that APC is 120. That's this guy right here. Okay, so that's 120. Okay. Let me just do some pieces. If that angle is 120, can you tell me the measure of this arc that I'm drawing? He's fast. Okay. That arc is 120 also. The angle and the arc should be the same degrees. Can you tell me the arc CB?
60.
Yes, okay, from C to B, that I'm drawing here in blue, that's going to be 60. Why? Because it's a semicircle. All the way, it's a semicircle, 180 degrees. So if I subtract the 120 from 180, that leaves 60. In that case, what's the blue angle going to be?
60.
Also 60. Let's see how many questions we've answered so far. Let's see. We're supposed to find the measure of angle BPC. Okay, so BPC, that's the blue angle. That's 60. We're supposed to find angle BAC. So BAC. We haven't found that one yet.
60 divided by 2.
Excellent. I heard 2 people give me the right answer. We're supposed to, BAC is this angle up here. That's going to be 30 degrees. Why? Because we're looking all the way over at this arc. The arc is 60. It's an inscribed angle, so it should be half. All right? I heard a couple people saying that. Does everybody see why it's 30?
Yes.
Okay, so that's half, so that'll be 30. What about arc BC? Yeah, it's 60. That's one of the ones we found right away. AC is 120. It's right there. Okay, so that's number 5. Easy. How we doing?
Good.
Not too hard. You guys are feeling. Everyone's going to exceed. Remember, on EOCT, it's all you either meet, do not meet, or
Exceed.
you exceed.
Is it a grade?
It is 15%. You do get a numerical grade, and it's 15% of your grade.
No.
But I want everybody to exceed, not just meet.
Hey, that's not nice.
It's okay. I really didn't. Maybe it'll be on the video later. Okay, number 6. The measure of arc PR is 72. So let's just get that down. So this is 72 right here. Okay? Right away, my brain wants to say what this angle down here is then. What's this angle going to be?
36.
So that's going to be 36. It's the old inscribed angle trick. It's half. Now, on this type of problem, I want to emphasize something else to you real quick. This is going to show up a few times, so everybody listen. Anytime you have a triangle that's inscribed in a semicircle, see how this triangle is squeezed into the semicircle? That's always going to be, how many degrees is R?
90.
It's 90 degrees. It's always going to be a right triangle. It's always going to be a right triangle in a semicircle. If you think about it, it makes sense because look at the arc that it gets. The arc from P to S, that's a semicircle, 180 degrees. It makes sense that this angle would be half the arc, just like always. So that's 90. We needed to know that. What are we supposed to find now?
PR.
The measure of angle SPR. Okay, so SPR. So we need to find this angle up here where I just put an X. See why it's useful that I know it's 90? Because now I know 2 out of 3 of my angles. If I wanted to do it the long way, I could. What could I do?
180 divided by 2.
I could, well, not divide it. Right. I could start with, oh yeah, you could do it that way too. You're thinking of the arc, maybe? Yeah. There's multiple ways to do it. I'm looking at the triangle way of doing it. If I just stare at the triangle, really the quickest thing to do is just to subtract from 90 because I know it's a right triangle. So if I have one angle, the other angle is just going to be 90 minus. Okay, 90 minus 36, so 54. So no matter how you do it, it's going to be 54. Maybe you saw it this way. Here's another way you could look at it.
I did 180 minus 72 divided by 2.
Right, if you did the Ark method is equally fast. And I think this is what Stephanie and Connor did. Looking at the 72, this is a semicircle. So if you do 180 minus 72, you get this red arc. What did that turn out to be?
108.
108. So then if you got the 108, then the 54 is half of that arc. That you could do it that way as well. Doing it that way, you didn't need to know about the 90, so I guess that's a good thing. All right, moving on to the super easy. We've done problems like number 7. This is like the 4th time we've done it since we started reviewing. What's the property that happens when you have a quadrilateral in a circle? Supplementary. And specifically, what is supplementary? Opposite angles are supplementary when you have an inscribed quadrilateral. So obviously, what's the answer then? So that's B. W and Y are supplementary. W and Y are opposite angles, so that's why it's B. Okay? We did that a million times, so I'm sure you're good on that. Let's see, what about number 8? What's going on here? ST, arc ST is 70. That's this guy right here. Okay, so that is 70. That means, what's the measure of this angle at P? 70. Thank you, Clara. Where are the rest of y'all at?
70.
So that's wow, okay. So, yes, I sure did. That's going to be 70 as well. Does anybody know what the angle here at T is going to be?
90.
Only Connor. Good job,
90.
Connor. It's too late. Connor already did it. Y'all are late. Now, I'm worried since only Connor answered, that made me think that maybe the rest of y'all did not remember this. Please remember, this was one of the major principles that we learned. Radius and tangent, they are always perpendicular. Let me say that again. Radius and tangent are always going to be perpendicular. So that's how we just glanced at it, boom, 90 degrees. We knew it immediately. So we've got a 90-degree angle, we've got a 70-degree angle, and they are asking us for the third angle.
20.
Boom, 20. Who said that?
Me.
Connor again. 2 points, Connor. Okay? So that's going to be 20. How do we get it? The quickest thing to do is just to subtract from 90. Just to do 90 minus 70. That's the fastest. If you keep forgetting, you could always go back to 180 and subtract 90 and 70 and get the same answer. A little quicker to just do 90 minus 70. Am I losing anybody? Now, even my geniuses, pay attention to number 9. I helped a few people with this personally, I think, like one-on-one. So was that this class? So like 6 of you, I already talked to you about this. But the rest of the class, you may not have seen a problem quite like this before. So focus. It might be a little brand new. At a glance, it looks like maybe it'll be one of those problems where I'm doing part times part equals part times part. Oh no, that's not what we're going to do. Because look at this part right here. BP, that's blank. There's not a number. We're not looking for it. So that's not what we're going to do. Instead, we're supposed to find x. That's not part of my part and part situation. So I need something else. So here's what we do. Similar triangles. It turns out that when you have a situation like this, these triangles will be similar. It might have been a while since you've done similar shapes, but you guys used to do proportions with them all the time. You set a fraction equal to a fraction. Let's start with the thing that we're looking for, x. I'm going to put that in the top. Now, look at the other triangle. What's the corresponding part on the other triangle? 6. Can you see it? On the top triangle, x. On the bottom triangle, the corresponding part is 6. So I'll build a fraction out of those corresponding parts. Now I just need to build one more fraction out of another pair of corresponding parts. Top triangle again, I've got 4.5. Now, what's the corresponding part in the other triangle? 3. It's the 3. Okay? I should have made this one different. 4.5 and the 3 are corresponding parts. So notice it doesn't go diagonal. The corresponding parts just go straight down in this type of problem. So I will just do 4.5 over 3. Okay? Just match up your corresponding parts in that proportion. Once you have the setup, everybody would get it right from here, because what do I do? Yeah, you guys are experts at cross multiplying. So that's going to be 3x I think from previous classes, I remember that was 27. Divide by 3, and you get 9. Okay, that's why the answer to number 9 is C. Did I lose anybody on that problem?
No.
Alright, Kiara, how much sense did that make? Total sense, okay. Alright, and number 10. Is this the last one? Okay, looking at number 10. We are given xy is congruent to zy. So that means isosceles, boom, bam. We're given arc yz is 108. So let's see, that's this out here is 108. Well, if this is 108 out here, can you tell me what this blue arc is going to be?
D4. Oh, 108.
The symmetry. It's isosceles. If these chords are the same, then these arcs are the same. So this will be 108. Now, how many degrees does that leave for the other arc?
216.
What?
Wait, come on.
144.
Okay, that leaves for the green arc, I mean, it has to add up to 360, and we've got 108, 108. If we subtract from 360, this turns out to be 144. Okay? So, I'm being asked for this angle up here. What does it turn out to be? 72, because we do half again. So that's why it is C. Okay, any questions on the homework?
Nope.